functional programming. It seems you either love it or you hate it. Like everything in software engineering, it's a trade-off. So for today, let's focus on the good, the bad, and the ugly parts of functional programming.
Welcome to the Foojay Podcast, all your news about OpenJDK.
I'm joined here today by some very smart people, Alejandro and Deepu. Could you introduce yourselves and tell me how you got in contact with functional programming? Alejandro, could you start?
I got in contact with functional programming back when I was in college. I had some friends, and we were quite interested of kind of exploring everything which was outside of what they were telling us. You know, we had a very traditional education where we started learning Pascal, to learn then C, to learn in Java, and it's like, you know, there are all these weird languages. So we got into this. So I got in contact with like Prolog, Clojure, Erlang, everything like this, and somehow I got hooked by the more functional programming languages, Clojure, Haskell, and things like this, and that led me to then wanted to study it more. Then I actually moved countries to be able to do a PhD in functional programming languages. So yeah, I will be the typical example of you don't need a PhD to do functional programming, but yeah. Then I've been exploring Haskell and functional languages. I spent like 7 years in academia, most of my time teaching this kind of stuff. And then a few years ago, I decided that, well, industry was kind of an appealing place because I saw that most of the things that 10 years ago were, you know, in a corner for weird people using strange languages were now becoming much more mainstream. So even Haskell was becoming somehow used in industry, but you had the Scala. People in Java suddenly knew what a map or a flat map was. So I decided, well, that's a nice place where I can actually bring what I know. That's more or less what I've been doing in the last few years. So I've been slightly moving from Haskell, so for more pure functional languages, to JVM. I'm working on Kotlin, and you know, figuring out how to apply all these functional programming ideas there.
So applying everything you learned from academia to a language like Kotlin.
Yes, it's been interesting because I first went into a more direct, I know these things from academia, let's apply it, but it's been an interesting journey of also having the feedback of, why there are some things which are done differently in industry. And you know, there is a reason for this, and learning this and kind of coming into a new version of what I think functional programming is from what I thought it was 5-6 years ago.
Something we should continue on soon. First, Deepu, could you introduce yourself?
Yeah, so I'm Deepu Sasidharan. I work as a developer advocate for Okta. I'm a Java champion, and I co-lead the JHipster project among a few other open source stuff. So a heavy open source enthusiast. I wouldn't consider myself primarily a Java programmer. I'm more of a polyglot programmer and a generalist. So I kind of take the same approach for functional programming as well. I'm not like not a functional programming purist or anything. I use the tools appropriate for the situation. So functional programming is just another tool in the paradigms available. I first got introduced to it coincidentally at the same time I moved to the Netherlands. So I moved to a small startup working on release orchestration and deployment automation stuff, and they were doing a lot of Scala. And I have never done any Scala before. I hate it, by the way. So in that company, I had a lot of colleagues who were some of them probably functional programming purists who would have liked everything to be rewritten in Haskell or something, but for the time being, they were content with Scala maybe, but there were a lot of functional programming happening, and I had some colleagues who, we were doing a little bit of Java as well, like it was a mix of Scala and Java, and some of my colleagues who were into functional programming wanted to introduce that to the Java code as well. So, there were a lot of the friction that comes from trying to do pure functional programming in Java and all those things. But that's how I got introduced to functional programming. And In the beginning, I was a bit resistant because wasn't a heavy fan of all that added verbosity, especially in Java when you try to do functional programming, right? And wasn't a huge fan of Scala as well. But later on, I came to appreciate the goodness, the good aspects of it. And I think then I realized, hey, I was actually, because I was also doing a lot of JavaScript at that time, and I realized, actually, I'm doing a lot of this in JavaScript. I just didn't realize that I was doing all this, and I just didn't realize that, okay, that is functional programming, right? So yeah, then from that point, once I started appreciating a bit more of the good aspects of it, I did start to use that when the need arises or when there is an opportunity, regardless of the language that I was using. And I think recently I was doing a lot of Rust, and I found myself doing a lot of functional programming in that. So that's me and functional programming.
That sounds good. I'll also introduce myself a bit. My name is Ties van der Ven. I also kind of got introduced in functional programming in a sort of similar way, where in the beginning of my career, I did a lot of debugging for applications. Like I worked on this big monolithic application, millions of lines of code. And most of my time I just spent debugging. And I noticed that like if I would see a null pointer, I would just add an if condition. But then like a week later, I would get another error that the function calling that function would now have a null pointer because of course I returned null. Doing that a few times, I started slowly figuring out that maybe this is not a very sustainable approach to just keep adding if checks and just starting to see what's the actual root cause of this problem and slowly figuring out root causes for more and more problems until I sort of find certain things that worked for me that would solve those things. Yeah, years later, I saw a talk from Scott Velashin. That's one of my functional programming heroes. And suddenly, like all kinds of stuff that I figured, hey, that works for me, then those have names within functional programming. So I actually discovered certain things just by accident because I figured I wanted to find root causes. So that's how I ended up being a bit in functional programming. So like Alejandro, I have no academic background whatsoever. I just came here through being curious and trying to figure out what root causes are. And I found that functional programming was a very good way to learn those things. In that sense, another good question I have for you two is one thing I'm also struggling a bit with. Just a simple question. What actually is functional programming? Is my answer has changed quite a bit over the years. There's, I think, a bit of an academical side. There's a bit of a practical side. So what is functional programming for you, Deepu?
To me, functional programming is, more the paradigm where you structure your code from the point of readability rather than performance or something else. It's about structuring your program in a more readable way, in a more reusable way, and maybe depending on the language, of course, in a more reasonable way. So that's functional programming too.
It's more of the thing as saying what you want to happen, not how you want it to happen. Mm-hmm. How about you, Alejandro? Do you have any insights on this? Because you said you actually changed your way of functional programming from academic to practical.
What I often say is that, so functional programming is as well, this idea of using functions, and that already is quite nice. I think that the latest shift to like everybody knowing what the map function is, for example, shows that this kind of code, and that's a bit what unites all those languages that are called functional, from let's say Lisp to Scala. What I like to do, and the kind of functional programming I like to do, it's like a strongly typed functional programming, if you would like to spell it out completely. So for me, the main three things is, well, first of all, you kind of use functions and this idea of passing functions around to structure your code. And as I said, well, that means that things like map and this kind of ways to traverse structures are nicer expressed. The second thing is that you take a lot of care on defining types for everything in your domain. So I think a very important thing is you use data classes, you use you use enumerations, you use case classes, whatever the language gives you to have these small repositories of data. And then the third thing, which I find important in the style I like to do, is thinking about effects. And with this, I mean thinking, okay, should this function at this point talk to the database? If it does, then I think it should be somehow explicit. And there are many ways to do it explicit. Types is the one I like the most, but there are other approaches, and I still think this is functional. So it's about carrying this thing, not just randomly, having dependencies all around and talking to stuff and doing network everywhere. I think this is another important part. Actually, when you take this to the extreme, and I actually like to do that, things like, for example, errors also become part of this effect that your function does. So if your function may fail, this should also be apparent somehow in your types, in whatever way you're doing. Maybe, just to give another point, so you have Elixir where you don't have types, but people really take care of doing this in a nice way. So they document this, and I think this is still the kind of programming I would consider to be this explicit functional programming, if you want to say it.
So, but there's mostly things like try to make illegal states not representable. Basically maximizing use of your compiler that it can help you with all your problems.
I heard a talk by you once where you said it's like about being in love with your compiler or something like this, and I thought that's a very poetic yet true way to put it. Yeah,
that's I think that's originally also the Haskell idea behind Haskell, that if it compiles, it works. Just making sure that move as many errors from runtime towards compilation time. I have a bit of a, in that sense, controversial against basic counter to what you say. That for me, functional programming, I think at its core, it's mostly functions and function compositions. If you have two small functions where one from A to B and one from B to C, you can just compose them to create a new function from A to C. I think that's the core in functional programming, as in starting from really small building blocks and using those building blocks to create bigger and bigger programs. From what you said, I see three core problems. That is state management. Like those are all things created with data. Also things like null pointers come from there. There is effects, like side effect management and purity of functions. And there's error handling. And I see those as three just major problems in functional programming. But in a way, I dare to say they're not directly functional programming related, more software engineering fundamentals. As in, object-oriented programming has these same problems.
Right. We can never shy away from the fact that our network somehow is disconnected, right? And people input wrong data. So that's I agree with you that's a more general problem of we have to handle those.
And I have a bit of a theory on that. Like, why is this so much more prevalent in functional programming than in object-oriented programming? Because they have exactly the same problems, but for some reason, functional programmers can't stop talking about these things, and you don't hear them as much from object-oriented programmers.
Nice to hear those terms. Huh? Functional program is an object-oriented program.
Yeah, but that's the thing. Like, I in a way, I hate those terms because there's first of all nothing inherently wrong with either approach. But one insight I had is that, at least in my level of education, I basically learned programming by, here's some if statement, this is how an if statement works, this is how a for loop works, this is how Spring Framework works, basically, and hey, you can be productive. What I kind of decided to call that more the physicist approach to software engineering, where in physics, we live in our universe and we're trying to discover what the laws of the universe are. So I start at the top. I just got the basics, and now I slowly start to learn what programming actually is. Well, academia usually starts with the axioms of programming, the absolute basics, and try to work their way up on how can you actually be productive with this. I don't know if that was a joke or not, but like how to do a print line in Haskell was like chapter 5 or something. to give a bit of an example of that. Alejandro will probably know that.
Yeah, so I kind of see a point there. I think that's also kind of a stereotypical way to do this, to approach this, right? I still think that we don't often remember how we learned programming. And I mean, I was a teacher of programming, so we also start with this, right? I mean, it feels weird, but people usually take a month to understand if statements and things like this. So we also start in that way, like composing a small pieces. So I wouldn't call this a physicist approach either. We also start with this. It's true that usually imperative programming, sprint line, or things like this is much more, it's at your fingertips, and there is this, there is this Haskell joke that it usually takes you a lot of time to print something to the screen. But to me, that raises the question of, okay, why is it possible to actually spend, for example, 4 chapters in Haskell without actually printing to the screen? And the reason to do this is, well, one nice thing which comes from functional programming communities are interpreters, right? So the fact that you can open an interpreter and have a piece of code loaded and then directly test it and see what the results are without having to build a main application which actually prints the things, it's what actually allows you to do this, right? You can just open Haskell, or Scala has it, or I think even Java has it now, that you just open it and you can say 3 + 2, and then you get 5, right? So that means that you can already start testing. And I think that that's a more interesting and valuable way to actually introduce programming that maybe the println approaches.
We're going to talk. Would like to talk a bit about in the teaching it. It was more that I noticed that a lot of these concepts, general problems, are more like somewhere in the middle between like the mathematic axioms and the top of the physicist, and that's it's generally people from academic background arrive at that point a bit sooner than people from a physicist point of view.
Yeah, I was saying that I call it the trial and error method because I can relate to T's more on that, because I never studied software engineering or computer science. I was an electrical engineer who accidentally got into programming and started tinkering around. And I learned everything by tinkering and trial and error, right? So same with functional programming. So I can relate to that more. I never had the academic exposure for functional programming. So I might not even understand some of the concepts from the academia side. It took me a while to understand what monads were and stuff, for example. So I had to figure it out by trial and error and tinkering as well. Some of my colleagues kept talking about monads, and I was like, what are they talking about? And then I saw what okay, that is what it is. So you could have just showed me. So and I just wanted to ask you, so would you consider yourselves functional programming purists?
I did in the beginning, but I think everybody goes in a way through that stage where you try to be to the point of dogmatic, as in I want to do this correctly. And I kind of moved on from that now. And now I don't think it's good to be a dogmatic functional programmer and just try to apply when it's at its best. And certain things are just not good for functional programming. And the way I see that, and I'm very curious also about Alejandro's opinion on this, is that most of the things in functional programming are in a way to reduce complexity. But the problem is, if you apply those to a relatively trivial application where there's almost no complexity, ironically, it starts adding complexity. So if you have a trivial problem where you just want to read a file and output the content on the screen, you don't want to deal with monads, error handling, side effect management and such. That's way too overkill. It makes that simple application a lot more complex. If you have a really complex application, then you kind of need to have these things to make sense of it in the long term.
Yeah, I have experience with exactly what you said. Being on the other side, I'm not a functional programming purist. I would use it if it makes sense. Otherwise, I'd go with what makes sense. If imperative makes more sense, I'll go with that. I have been in teams where there were functional programming purists in the team, and we ended up adding way more complexity because of trying to do everything the functional way. So yeah.
I think
that's a good approach.
I think
he has a good insight because he also works on the arrow library, the function programming library of Kotlin. So I think that's quite a different approach to this topic. Alejandro, what do you think of it?
it's interesting to me because I think that this kind of discussions about functional programming always end up on this pure thing. So it's also for me interesting as maybe somebody coming from functional programming first into other to see why people want to do this pure thing, right? And even to agree what pure is, and maybe the people who are listening to the podcast don't really know what we are saying when we say pure. And for example, I consider this when people, for example, say, no, I want to do everything super immutable regardless of whatever. This has to be immutable. And then I think this, to me, what happens there is a bit like with maybe design patterns, things like this. It makes sense if you understand the why you want to do this, right? We want immutability because that makes debugging easier, that makes scaling easier. That doesn't mean, of course, is the solution to everything. And to me, sometimes using this as overkill, as if you will introduce a file factory to read, for a small application which reads a file, right? Why would you introduce a factory pattern if all you are going to do is to instantiate a single class? I think in the past, for example, we also have for example, design pattern purists, right? Who always wanted to apply this kind of thing. And I see the same kind of overkill thing. So you see a solution to a problem and suddenly you want to apply the solution everywhere. But I would say that in this year, maybe I'm still a purist in that what I really have become very, very, I think it's very important in all the code I write is explicitness. I've become a purist, if you want to say, or very dogmatic about explicitness. I really want my signatures of my code to essentially tell all the function can do and never have a sneaky behavior to do this. And I find this just helps the teams I work with. So I thought that of everything that functional programming, as I said, strongly typed functional programming has to offer, that's the only thing what at the end of the years, I've become convinced that still pays off to be somehow dogmatic, purist, extreme, call it whatever. I think that's the main thing that I still want to do.
But I think the key part here, what you said, is that understanding the why. Why do you want to do a certain thing? Because once you understand that, it becomes a logical thing to do. And it also becomes logical when not to do it. Like indeed, immutability, I'm a big fan of that. In favor, it solves a lot of my problems. But if I have a function that needs to loop over 1 million elements and do a computation on that, mutable state is way more performant there. But what I like to try to do is that function should have an immutable object in and an immutable object out. And if the state in between is mutable, it doesn't matter. The rest of the application won't see that. And that would be, for me, a practical, I know exactly what I'm trying to do. The application should have immutability in, immutability out. And an implementation can have safe mutable state. That's not really an issue.
And I think that thing you raise is an interesting thing also, because that's what I've seen, for example, in languages like Kotlin, which I think it's a really great idea, is to expose the functional API. But actually, when you see what bytecode is generated, it's actually doing the looping, because whatever inline thing it's doing, which I think it's also an interesting approach. So I think in the history of programming, we've been very forced to actually have the same view in the low level and the high level, right? So for example, if Java decided that in the JVM they are not having generics, that means that you don't have generics in your language and you have to deal with it, right? Whereas you have a Scala and Kotlin would say, yeah, sure, my platform doesn't have generics, but I still have full-blown generics. And I think that's an interesting idea, which is going to become more prevalent, right? So have APIs which are nice and functional, yet have implementations which really do the terrible thing you maybe don't want to do by hand. because you want the performance. That's I think that's a given for almost every programmer.
I think performance is I think the key reason I avoid functional programming is always performance. Especially in Java. I mean, in Java, I avoid functional programming a lot of the paradigms. I think the only time I use functional programming in Java is if I can do something with the stream APIs or the optional monads, and those are the only things I sprinkle in. Otherwise, I generally tend to go with imperative or object oriented with Java. But I found myself doing a lot more functional programming in Rust because it didn't matter. The performance aspect didn't matter there because the compiler in the end was generating imperative code regardless of what I was writing, right? So I didn't have to care about that. But in Java, it's quite easy to check, right? You write something in functional and you write something in imperative, you run a performance benchmark, and you clearly see that the functional one is like twice as slow as the imperative one, right? So I tend to avoid a lot of that in Java, especially if I have to do process over a lot of things. I tend to avoid using functional programming there.
My question here is if it wasn't, right, if the performance was the same, would you then prefer the functional version?
Yeah, that's what I said. In Rust, I tend to use functional programming most of the time. So I don't even think about it. I just notice that, hey, I'm just gravitating towards that. Like I tend to use most of the functional APIs most of the times. I mean, of course, there are a few scenarios where I don't, but unconsciously I tend to gravitate towards that because I'm not thinking about performance there. But in Java, then I'm thinking about that. So I tend not to. So exactly as you said. So if that was not a problem, then I'm pretty sure most people might have, because it is convenient. The functional APIs are convenient. They are more readable and easy to reason about than imperative code, of course. Yeah, you need to get that confidence that you don't have to think about that to get there. Also, yeah, I think I try to write something about how to do every aspects of functional programming in Java. And to be honest, I wouldn't use half of that myself because it's not very concise to read in a language which is not meant to support that as a first-class citizen, right? So except for lambdas and the stream APIs, maybe the code becomes very unreadable. It does the opposite of what you want functional programming to do, right? It is not it kind of becomes hard to read for someone who is a regular Java developer, right? Because that's not how you write normal Java code. It starts to look weird.
And to me, that goes a bit on the same idea of exposing knife. So again, Java is kind of forcing you to go. It's like with properties, right? Java is forcing you to have your getter and your setter. Why is it forcing me to do this when any other language is able to declare a property? C# had this 20 years ago, right? So I have a problem with doing this kind of things, right? It tries to not hide complexity. I don't know why, but I think that's the approach of the language, right? That you also see this with things like Project Loom and so on, where they provide a very low-level API, which I think, that's a great API to build a library on top of this. But then what you read in blog posts is how to use this API directly. It's like, why don't you create something new and beautiful on top of the low-level API?
Sounds like a new library idea for you. Deepu did raise an interesting point, the cost of functional programming, because indeed there is the performance overhead. For example, with immutability, the only way to change the object is to create a new instance of the object. That causes a lot of extra objects on the heap, which damages performance. Can you elaborate a bit more on the cost of functional programming, Alejandro? As in, what problems does it give you?
When I think of the cost, I think there are two main costs. One is I think sometimes when you don't have the performance that you want from your functional code, because the kind of languages we use to do functional programming are usually built on top of, let's say, JVM or some other platform which is not functional, then you end up having to figure out what was the translation and figure out where the performance issues come from. And I think that indirection, it's hard. And maybe it's even something which functional programming always have. So if you hear Haskell people, one of the things they usually struggle is when I have a performance issue, when I have a memory leak, how do I find this? Because the APIs are very convenient, but they hide away complexity. And we sometimes need to unveil the complexity in order to understand where the performance issues are coming from. So I think that's one thing. The second thing is usually traditionally people don't learn functional programming when they start learning programming. And if you want to introduce functional programming in a team, you need, well, somebody to kind of push for it. You need people to learn this, and this of course has some friction, right? So I think that's not a problem with functional programming per se, but if you want to introduce functional programming, that's something that I think people have to be honest about. This is going to cost you. And some people say this will only be 1 month. Some people say that's going to be 3 months, but there is some period of time which people need to familiarize themselves with functional programming.
Looking at myself, it took me quite a few years to really get into the why bits. And yeah, there's the cost there where there are a lot of concepts that you kind of need to learn. And if you want to do it correctly, also what Deepu pointed to, that yeah, you really need to understand the why, when to use it. And that takes a lot of practice. So there's indeed the cost of, I wouldn't directly added complexity, but yeah, there are just new concepts you need to learn and understand. And if you're not used to that, that can be difficult to introduce into a team. People, do you have any other insights on this?
I think I would like to touch upon something that Alejandro was mentioning. It's about when you learn functional programming, right? I believe it helps that you learn functional programming after you learn something like imperative, object-oriented, probably not, but at least once you're very familiar with imperative programming and you can write something very closer to machine code. And then if you learn functional programming, I think that helps you to kind of appreciate it a bit more. Because I have come across folks who, again, probably similar to me, they didn't have an academic, path to learning programming, learned on their own, and they kind of started directly with a language, maybe like a functional programming language, or maybe with Scala, or even like a functional programming in JavaScript kind of thing, right? They tend to kind of overuse it, in my opinion, and kind of use it as a silver bullet, and not understand, as you mentioned, not understand the cause or when and why aspects of it. So I think it would be, so I agree that it would be nice if when people are learning programming, they learn also functional programming, but it would be nice if they do it after they learn imperative or some other paradigm.
I actually want to challenge that, because isn't this just the definition of a junior developer? I mean, whatever a developer is starting, usually, they come with a set of things they learned and they believe are the way, right? And be it functional programming or whatever, they tend to have a very narrower view. So I want to challenge that this is a functional programming thing, and it's more like a junior developer thing instead. I don't know what your thoughts are about that.
Yeah, definitely. It can be that. So my point was, regardless of if you're a junior or whatever, right? Like my point is that it helps to appreciate functional programming more when you actually learn some other paradigms.
That's an interesting point. So you want to learn the bad so that then you see how nicer it can become?
Well,
that's
in a
an
way,
interesting
I would
idea.
like to challenge that.
That is how I learned it. Basically, I was making mistakes and I figured out solutions for those mistakes. And that's basically how my love for functional programming started to come. Because I saw how it fixed things that were going wrong for me.
I want to kind of understand why you both seem to think that this is an important step or an interesting step with respect of the other possibility, which is if you start blank slate, you, let's say, learn both paradigms at the same time. Why do you think that it's important to make the mistakes to then appreciate it more?
Well, it's something that worked for me personally. I wouldn't say that's the only way, but that's how I got in contact with, but I also didn't have someone to teach me functional programming.
I'm not saying the other paradigms are the bad ones. No,
I
say all of them have their need, all of them have their place, and all of them have their strengths and cons. To me, at least, similar to what Tay said, to me personally, already knowing imperative and object-oriented helped me to appreciate some aspects of functional programming, also helped me to not appreciate some aspects of functional programming. That's why I would never use functional programming wherever I go. No, I'm not. I'm going to use it when I think it is appropriate. So as I mentioned, so if I'm writing Rust, then yeah, maybe I'll just do function programming everywhere if possible. Again, I'm not going to do pure function programming there because sometimes it's not practical. Sometimes it just adds more complexity than it is required. Sometimes just a simple for loop is less complex in some situations, right? I'm going to do that. But having all these in my tool belt helps me to make the right choice, helps me to appreciate when to use what. So it helps me to appreciate, hey, okay, functional programming is going to make this part of my code very readable, concise. It helps me to appreciate that. And sometimes it helps me to not make the bad choice and add unwanted complexity because I'm not familiar with the other concepts and I don't appreciate those, right? So for me, it's about knowing the different options, having different options so I can make the right choice. So that's why I mentioned if someone does that, then yeah, they probably can do the same thing. And I see a lot of this in our industry, right? Generally, there is this push that, okay, functional programming is the ultimate way of programming. And there is a chance that a lot of people who might start with that will get stuck on that and they will never explore the other options. And regardless of their junior or senior, I mean, I have seen very senior folks who would not touch any other paradigm because they are very hardcore on functional programming and they end up adding unwanted complexity. So I wouldn't say it's 100% a junior thing. It's more of getting too much tied into one way of doing things.
Yeah, there is a bit of a dogmatic elitist thing, but
yes,
that is true. Although that's also in object-oriented programming here and there. So that's everywhere. But yeah, I do think that's a bit of a problem. Same with how it's explained, which is usually in very academic language, which makes it harder for people. Like you mentioned at some point, hey, what is a monad? Well, if you look at the definition on the internet, you don't know. You just see like 12 new words that you never heard before. So that's not going to help. Yeah. So that's a bit of a problem with that.
I actually want to challenge that, right? I think that the industry has become, and I'm a bit afraid that we keep repeating this stereotype and then we help perpetuate it. I mean, we are in a regular podcast talking about functional programming. We all use functional programming in our jobs, and there are books being written. In short, I think what you said was true 1 decade ago. I think it's no longer true. There is this elitism is really gone. I think that most people nowadays have these concepts, and of course there is always a few people who want to feel superior by knowing the mathematical definition of a monad, right? But I think you can now learn what the monad is even with the 10 million blog posts explaining this.
Basically going to be my follow-up point. so
okay,
thank you for that. But yeah, that's exactly the thing. That's also something I try to do in all my talks about it. Just make it accessible, as in you're probably using all these things already without maybe knowing the names behind it, and it has become a lot more accessible these days.
Yeah, exactly. I had a huge issue with the academic way of defining things. So that's how, because when I got introduced to functional programming, I was like higher order functions, monads, this, that, like referential transparency. I was like, I was like, what are these? Like, okay, then I started getting this, this imposter syndrome, like got blown up that because I didn't have an academic background or like I didn't have a computer science education. I was like, oh, I just don't know a lot of things. I'm just stupid. Like, right? Then I started trying these and I was like, okay, referential transparency. I'm already doing that. So why can't you just say that, why can't you just say that it is about immutability? Why do you have to say...
Well, that's the approach I try to show people that you're already using it. But I do notice myself that learning these definitions does help me. Like learning how something is called by the correct name does help me think about it in a different way. So I learned it by exactly what you say, like I'm already doing this. And now slowly I'm starting to use the word monad, for example, more and more. Because it's shaping how I think about programming. So terminology does help in ways of thinking. So I can encourage people to learn it over time, but you don't need to know it right away. I used all these things for years without actually knowing the proper names for it.
I think most people do. Most people are using most of those without knowing those terms, right? So I agree. It is important to know the terminology at some point, but to make it more accessible, I think it helps to kind of use the terminology, but also explain it in simpler terms, in more universally used kind of terms, right? So it hits faster, it registers faster.
I wanted to go a bit in there. That leads a bit into the teaching side. I want to make 2 points of this. So first of all, one thing that I think, as to be clear, is that even if you want to go into functional programming, you will have to learn something, right? It's a different thing. And I think it's very even irresponsible from us to say either, oh, you don't need to know the whole definitions and all the whole book. That's right. It's not true either that you don't have to learn anything, right? You will have to put some effort. And I think like with the passing of time, I've tried to be more honest about this. I used to tell people, oh no, it's so easy. No, it's, you will have some learning curve. It could be a steeper or shallower, depending on how deep you want to go into this concept, but you will have to learn, and you will have to unlearn some things you know. And this goes a bit into the point I wanted to make, which is that's a bit, to me, like, I don't know if you've tried, but the difference between teaching kids or even, teenagers, people who something for the first time, it's different, very different from teaching grown-ups something. And you can see this, for example, in language, right? When you're a kid, you learn language by trial and error. And everybody around you kind of tells you when you're doing something wrong, tries to help you. That's how a kid learns language. When you are an adult, you have a book which tells you the grammar rules of the language. And it's very hard. It usually, you say, why do I need all of this? I just want to say hello. And to me, this happens a bit with functional programming. We turn to learn functional programming at a point in our career when we've already learned the other stuff. So we learn it from a book. We learn it from a more, let's say, academic, but maybe more book-like perspective. And we want to be very productive very soon. We don't give us the room for trial and error. We don't give us the room for experimentation. And that's why I think where all these questions come from. Okay, but why do I need to know what referential transparency is? Well, it helps you. And if you had learned this from the beginning, you would just have grown with it. That's kind of the point where I am. And I see this again with teaching anything, I think, to a grown-up, right? Try to teach somebody why they suddenly need to make their taxes on their computer instead of on a piece of paper, right? And they will say, why do I need this? I think it's a bit of the same kind of thinking that goes when people have to learn functional programming.
I think that's a very good insight. But you have to be kind to ourselves and others that, this is something that you don't get to be productive instantly. These things just take time. And I do hope that if of this podcast that people accept that and also spend a little time in learning functional programming. And how do you see the future of functional programming, Alejandro?
The main thing for me is that functional programming is here. I mean, I always tell my my friends who are also doing this, like, we already won, right? Like, Java has records, seal hierarchies, and functions. So it's all I want from a functional programming language. So in that sense, I think it's just there. It's inevitable. And I think the last missing thing, which was all this kind of concurrency threading idea of having lightweight threads to have many things, it's already there with Project Loom. So on some sense, it's inevitable.
The future is now.
The future is now. What I would like to see is that people start asking for compiler writers more than they used to. And for example, I think if you do Kotlin and then you use their nullability analysis, where you cannot have null because the compiler keeps track of this, to me, the main question is, being an academic and knowing that kind of analysis already existed in the 1980s, why does Java in 2020 doesn't have that analysis, right? So I think we are going to see, I hope that we see something where people say, oh, my compiler can do more. Let's track more things. Let's try to make it help me. I think what Ross has done is incredible, right? It's tracking your memory. So you cannot leak it. Why can other languages have this kind of thing? And I hope this is the future of what we see in the next decade or so.
Sounds quite cool. Deepu, what do you think about future? Do you have anything to add to that?
Yeah, definitely. I mean, since this is a Foojay podcast, right? I think we have to talk about Java, man. We have to talk about Java. I love Java. I'm a Java champion. I'm going out and teaching Java to folks, but I'm also the biggest critic of Java personally, right? I would love to see Java grow more. I would love to see Java compiler becoming smarter, because it's hard not to notice in other languages, especially if you're polyglot, right? It's hard not to notice things missing, right? I would love to see zero cost abstractions in Java. Then you don't have to worry about some of the performance cost of functional programming, for example, among other things, right? I would love to see tail recursion in Java, so that you can write proper recursion without having to worry about stack overflows and stuff like that, right? So I would love to see a lot more of these underlying compiler features in Java. I would disagree that the functional programming feature is already here in Java. I don't think it is already here. We are getting there maybe, but I personally think we still have a long way to go, because I still think you can't write, if you really want to do full-blown functional programming in Java, I don't think you can do that yet, unless you go out of your way and start using all those functional interfaces everywhere, which kind of, in my opinion, makes the code less readable than object-oriented or imperative in Java. So I would like to see that improved. I would like to see more native support for maybe first-class functions and not just Lambda, right? I would love to see the compiler grow more, become in line with more like something like the Rust compiler or something, right? I would love to see that. So yeah, I think we are getting there. So we are going the right direction, but maybe it would be nice to speed up a little bit more.
Personally, I think you can't add anything to language. I think you took over that really well. I would like to see a bit more, like in teaching aspect, to the abstract thinking part. What are the underlying problems? Although people also kind of need to figure those out themselves if it really wants to stick. But I do think indeed, as in the future is now, I do notice a big difference now and years ago. So that there is a bit more incline into this functional features, and I hope that continues, because I do like the whole making illegal states not representable, moving errors to compilation time, being explicit in code. I think those are very good things in general, and I like it that they're coming up more and more.
Yeah, definitely.
Any last thoughts, Alejandro, Deepu?
Yeah, I would like to continue on what you said. So yeah, I think a lot of things changed from that teaching aspects and the general acceptance aspect, because lambdas and the monads of Java, like optionals and all these things, right? They are very, very normal now, right? So they have become mainstream and kind of have become the de facto when people write code, which is a good thing. So I think teaching wise, as you mentioned, the language features, yeah, we are kind of maybe at a level there, probably not a lot to add other than optimizations to a compiler, but maybe from the teaching aspect, I think functional programming can become a central aspect of teaching Java, maybe along with, of course, object-oriented and imperative. I do see a decline in pure object-oriented programs written in Java. I don't know if you also notice the same, but maybe that's a good thing. Maybe we are seeing a decline of people because Java used to be object-oriented programming's love child, right? So I think that is changing. So that probably is a good thing.
I think it's a good thing, mostly because there are certain problems object-oriented programming is really strong in, and there are certain problems functional programming is really strong in. So in practice, the combination is always better. Like Ryan Getz, the Java language architect, also said in one of his talks, don't be a functional programmer, don't be an object-oriented programmer, be a better programmer.
And yes, exactly.
I think that was very inspiring for me. And that's it. Like you also mentioned a few times, you should have a toolbox full of tools and apply the correct tool to the correct problem. And in practice, that's going to be a combination of all paradigms.
Plus one on that. That tends to be my starting line whenever I write about functional programming. Don't just use that. You, depending on the language, use whatever available to you.
You have any last thoughts, Alejandro?
I don't use Java for most of my day. I write Kotlin, so I'm starting to actually get jealous of what it's coming in like Java 21 and all of that. So I consider, for example, pattern matching to be a very nice tool if you want to write functional code. You don't have that in Kotlin, but you have it in a Scala, and it will come in Java 21 for records. So I think this kind of additions will hopefully means that all of this becomes more mainstream. I don't know. It's also, I think, nice to see how some of these ideas are also impacting other parts of the process. So I don't know about you, but for example, I even hear about declarative DevOps, which I think is a nice twist that I wasn't expecting on this whole story, like functional programming becoming popular enough that people in ops think, oh, maybe we can apply some of these ideas here too. So that's, I don't know, a small twist that I see that we can see that more broadly these ideas are going into our industry.
In your statement, the future is now. That's also happening in other areas, and I think that's a good thing to close on to. Thank you both so much. I got quite some good insights from this. Had a really nice conversation. So thank you both for coming, and thank you all for listening.
Give me a foo, give me a J, give me the friends of OpenJDK.